Hello everyone. I'm Rajeshwari from SNS College of Technology in the Department of Artificial Intelligence and Machine Learning. In last class we have seen about decision theory and probability distributions in machine learning. So decision let's we are going to recall the topic. Decision making is which is may helps make best decision under uncertainty, and evaluation is which is uses probability and utility to evaluate choices, and machine learning plays a crucial role in machine learning and artificial intelligence in real world applications widely applied in real world intelligence systems. And here the learning objective is to understand the meaning of bias and variance in machine learning models, so differentiate between underfitting and overfitting, and the explanation of bias, variance, and trade-off to identify how model complexity affects prediction performance. And the definition of uh, bias is the error caused by oversimplifying assumptions in the learning model. So here the diagram will denote high bias model. The pros and cons of high bias model is the pros is simplicity and computational efficiency, and cons is underfitting, poor generalization, limited real world effectiveness. So this is the pros and cons of high bias model. And the definition of variance is the error caused by the model being too sensitive to training the data. So here the diagram will represent the high variance model. The pros and cons for high variance model has the pros is excellent training performance and captures complex patterns, and cons is poor generalization, overfitting, and sensitivity to noise. And the next thing is definition of bias, variance, and trade-off. Here it is the balance between bias and variance to achieve minimum total error. So balancing model complexity of accuracy is fails to capture patterns, inadequate predictions, and overfits the data and difficult to interpret. So here overly simple model and complex model. So under complex model it has the overfits the data and difficult to interrupt, and simple model it has to it is the fails to capture patterns and inadequate predictions. So this is the bias, variance, and trade-off, which is mainly to achieve minimum total error. So the analysis process of bias and variance is, the first thing is we have to select a model, train the model, evaluate on test data, analyze errors, optimize. So the first thing is which we have to select a model to choose between simple and complex model, and train the model is for learn patterns from training data, and evaluate on test data is for to check generalization performance. Analyze error is for to identify bias or variance issues, and optimize is for adjust complex adjust model complexity or data size. So these are the bias, variance, analysis process. So we have to select the model, train the model, evaluate the test data, analyze error, and optimize. So how to reduce bias and variance in model is for to reduce bias, it increases model complexity or add more features to fit the data better. And to reduce variance, it is for increase training data, use regularization, or apply cross validation to improve generalization. So these tools are the process to reduce bias and variance in the model. And here the graphical representation of bias and variance. So the model x-axis will be denoted as model complexity and y-axis will be denoted as prediction error. So prediction error, we have to finding the prediction error, which is equal to bias squared plus variance plus irreducible error. So these are the thing we have to calculate the prediction error by using the bias and variance. So next class we are going to see about next topic. Thank you.